Now we're going to check out the Big Tree Tech SKR Mini E3 board version 2. Chris here, back again with another main board you can use on your 3D printer. But this one is just a bit different. A couple of months ago I did some videos on the Big Tree Tech Mini version 1.2 board. I have been using those on some of my printers. I haven't had any issues, but others have seen problems on that board. Some haven't been able to use that board on their printer at all. Well, Big Tree Tech released the version 2.0 of the mini board, and that does address a lot of those issues, as well as add features that make the board a lot more convenient to use. And the price point has pretty much stayed the same. So today we're going to take a look at both boards side by side, see what the new features are on the mini version 2, check out the firmware a bit, get the board installed and do a test print, and just see how this whole thing goes. It should be a direct swap out with the firmware configured on it already for the Ender 3, but you can use it on a lot of different Creality machines as well as other printers if you want to adapt it to your control box, whichever environment you might have. So let's get started and take a look at the 1.2 versus the 2.0. So here we have a look at the board side by side. We have the version 1.2 on the right here, and the version 2.0 over here. Now there are a couple of things that are pretty obvious just looking at them side by side that has been upgraded on the 2.0. They have added a Z motor plug, so you have two if you have a printer that has two motors. The bed MOSFET is quite a bit larger, so it can handle a lot higher current. And just overall, some of the pin locations have been changed around. They look just a bit different, but we'll go more into that in depth in a moment. Just note the processors have not changed. They are the same STM processor on both boards. One thing that might be easier to show you in this side-by-side view is where the location of the stepper driver is now. On the 2.0, they moved it further out, so it was away from a lot of the other pins and components. When putting these heat sinks on, it can be somewhat of a concern that you're going to short something out while installing it. So just to be safe, Big Tree Tech moved that chip so there's not a lot of components around it, so you're less likely to get a short. So now let's take a closer look at V2. So things I've already mentioned, but that processor is an STM32F103, just like the other board. You do get an upgraded bed MOSFET and two Z plugs. One of the biggest changes on this board just so happens to be this chip right here. And that is an EEPROM chip. EEPROM is a memory chip where you can save some settings so you don't have to flash the complete firmware on the board. And on the other versions of this mini board, you had emulated EEPROM that used the SD card. Now they've installed a proper EEPROM chip. You don't have to worry about that card getting corrupted anymore and losing your settings. It can all be saved right here. And some of our new pins that we have changed up, right here you have a port for BL Touch. You can plug in all the servo wires and the in-stop wires side by side to make it a little more convenient. You have a port for filament detection, power off detection, and pins you can use for automatic shutdown. Of course, you can use these for other things if you'd like to configure them. You have your jumper right here, so you can use the onboard 5-volt power supply, or you can switch it over and use that Big Tree Tech module that they offer. That comes in handy if you're trying to use a lot of NeoPixel lights. You now have two sets of fan pins right here that you can control via the firmware. That's always really handy, especially if you want your hot end fan to be off after a certain temperature. And they have an upgraded power regulator chip. On these boards, that's a pretty common issue to see the regulator go out. You'll lose 5 volt, maybe you'll notice the LCD screen doesn't light up anymore. This chip is a big improvement over the previous one. The 2209s are now using a hardware UART port, and they have pins on each one where you can control sensorless homing. On the previous boards, you would have had to use a jumper or something like that. Now it's integrated. You do still have to configure it in the firmware, but you can put these caps on to use it. And onto the back of the board, they have made the badging back here quite a bit better. It's a little easier to find the pins. More of them are labeled in the previous boards. They've added extra copper underneath all of the drivers so that heat dissipation has improved greatly, as well as this PCB is now 4-layer. So it's just a little bit thicker. That should help as well. We also now see that we have the open source hardware badging, which is always good to see. And that's pretty much all the features, and all we need to do to get ready is put some heat sinks on our stepper drivers. Now I won't be using centerless homing today, but if you would like to use it, just put your jumper cap, the little red ones that came with the board, on these two pins for the drivers you want to use. This is X, Y, Z, and E. I will show you how to enable that feature in the firmware if you want to use that. The drivers will just glue on top of your chips like so, and then we'll do the other three. And now we're ready to install it on the printer. So there's a look at both boards and their features. If I was going to choose a mini board, I would definitely go with version 2. It has the best feature set. Now, installing this board is pretty straightforward. I've shown this before with other mini boards. We will go ahead and walk through it on this Ender 3, but remember, it will fit the Ender 3, Ender 3 Pro, CR10, Ender 5, as well as a lot of other machines. But Big Tree Tech does have firmware for a lot of the Creality machines that you can just apply. So let's go ahead and get it installed. So I've removed the previous board already. I did have a Panicut board in there before. And I am running the Hemera extruder, so I will need to make some changes to the firmware after the fact, but we'll go over that. These boards just install with 4 screws, but I do like to install the power before I put it in because I think it's just easier to do. So the board will slide in this direction. This is your DC power in. Your ground is on the outside, power is right there. You'll notice I do have ferrules on all of the bare wires. They're going to be soldered from the factory. I like the ferrules better, but just so you know that this might not look exactly like your printer does. So our power wires are installed. I'm going to go ahead and put the board inside the case. When you put it in, just make sure your USB port up here and the SD card are lined up at the front of the case. And then you have 4 screws. One up here by the SD card, you can barely see. One kind of out in the middle. One over here on the right, and then one back here. Now we can go ahead and continue wiring it up. I like to start on the left and work to the right. Now this first set of terminals over here, this is a constant power on. They're actually meant to use the hot end fan here, like on the standard Creality board. Now this next set of terminals we come to right here, these are constant terminals, so they're always going to have voltage. They're meant to be used for your hot end fan, like on the stock Creality board, it's on all the time. This side would be your positive, this side would be your negative. Now if you have the stock Creality board that you're swapping out, you're probably just going to have bare wires, so you can use these. My hot end fan has a JST connector on it, so I'm going to put it on another set of pins. We'll see that in a moment. But if you need constant power, or you have one of those fans, use these two. We're going to skip it on my install. And then we'll go to the next set of pins, which are for the heated bed. Most of the time your heated bed is not going to be polarized, but if it is, you'll want to use this for positive and this for negative. That's usually not an issue. It's just like any other heater. It's not going to have polarity. Our heated bed wires are on right there. The next set will be your hot end heater wires. Again, no polarity. The hot end heater wires are on right there. Remember, it doesn't matter which side's positive or negative. Just put them wherever you want. Your wires will probably be red, mine are yellow because I'm using the E3D heater and they use yellow on 24 volt. Moving on, our next set of pins right here. This will be for your part fan, and we're going to use this set of pins right here for our hot end fan. These can be controlled in the firmware. We'll see that more in a moment. Hot end and part fan are plugged in. The next one down right here is for your X end stop. Next to that is your Y end stop. And you guessed it, the next one is your Z end stop. And then just like on the other board, we have our bed thermistor. And then all the way down here in the corner, you can barely see it, that is your hot end thermistor. Now let's move across to the motor wires and we'll plug the LCD in last. In the very back up here, we have our X motor. Next one down is our Y motor. And then we have our 2 Z motors. Doesn't matter which one you use, but if you have 2 Z motors, there's a plug for it. I'm just going to go with the ZA pin right here. And then over here in the corner, that is for the extruder motor. And you'll notice I have one set of pins right here. I actually still have the original extruder motor hooked up, it's just not plugged in. This other one is for the Hemera. So there is one more fan we need to be concerned with, and that's the one that goes on top of this case that covers this board. You'll have to make some decisions here. I am going to go with my hot end fan in this pin, and then fan 0 will have to be your part fan, because that's how it's controlled by default. But then that leaves you with no pin out for that case fan. So you can either use it on these pins here, or you can just have it on all the time back here on that constant set of pins. So it's kind of up to you how you want to configure it. I'm not super worried about that case fan, so I'm going to leave it on for now. Just keep that in mind when you're wiring this up. I'm going to kind of give you a side view here, but last but not least, your LCD cable goes right up here. And there we go. All the wiring is done. So all the wiring's done, but that case fan, you will have to get just a little bit creative with it. Maybe let it run all the time on those constant pins, but get a little quieter fan. This one is kind of loud. It wouldn't hurt anything to have it run all the time. 2209s, like on this board, do run pretty cool anyway, but experiment a little bit and see what works for you. I'd rather have the Hotends fan controlled myself. Now, let's power up and make sure everything works before we tweak the firmware. Screen came on, that's a good sign. It says it is Marlin Bug Fix 2.0. Note that I do have the BL Touch on here. I am not going to hook it up today. But let's just auto home real quick. And everything appears to be working as it should. It did auto home successfully. Funny is that Hotends fan came on full blast when I did the auto home. So that must be how it's set up in the default firmware. Just note that I am going to change it up in our Marlin config. Now I can't test print or anything at this point, because I do have the Humera and I have to make some changes, but we're going to do that next. Now, Big Tree Tech does have some firmware out here that you can use. You can just slide that Firmware.bin file on your SD card, put it in, turn it on, and flash it. They have one for Ender 5, BL Touch, Z Homing BL Touch, a couple of different configs. But I would rather show you how to build it from scratch, because there's example configurations out there in Marlin now that make it super easy. Thanks, Keith. And it is important to note that the first full version, first stable version, that supports the 2.0 board is 2.0.6. So let's go grab a fresh copy of that right now. We'll just head to marlinfw.org, head to downloads, and latest release 206. Well, let's download this zip. We'll just head to downloads, right click, and extract all. And I'm just going to rename it 2.0.6. And then I'll put mini V2 on it, so I know which one it is. And we'll hit extract. And while that's downloading, we need the example configurations that we're going to use for this video. So just go Marlin GitHub, and then on the home page of the GitHub, go to config. And if you click this link right here, that will get you all the example configs for the stable release, 206. And when you extract all that configurations release, we'll just go into that folder. We'll go into config, examples, and we'll go down to Creality, Ender 3, and then they have created Big Tree Tech SKR examples for the Ender 3. You've got the 1.0, the 1.2, and now the 2.0. And that is super handy. So we'll just go into 2.0. We're going to grab all four of these files. We'll right click and copy. And then head back to downloads. We'll go into our newly extracted Marlin 2.6 folder. I renamed the folder underneath it. Remember, you need to add the parent folder of the Marlin folder. So if you go in here, and then go into Marlin, we're going to paste our config, the one we copied out of the examples, and we're going to allow it to replace the files. And then we'll go back up. There's the Marlin folder. This is the parent folder of Marlin. This is the one you need to add to VS Code. A link to my VS Code video will be in the description below. So now let's open up VS Code. Over here in the bar, the top one up here is the Explorer. Make sure you're there and then right click out here in the blank space. We're going to add folder to workspace. We're going to add the folder that's the parent of Marlin. Hit add. And then we'll expand Marlin right here. And we'll open up configuration.h. Now if you don't have your platform I/O icon over here, that's what you need to build. You can go to extensions right above it and download it. That's all in the VS Code video. But back to configuration.h, I need to make a few changes. The serial ports are configured if you'd like to use a touchscreen as well, so you don't need to make those changes. It should just work if you plug it in. We are set to 115200 by default, and here is our V2 board name, just for reference. Temp sensors, I am using an E3D, so I'm going to change my extruder to number 5, because that's the thermistor they use. Notice the drivers are set to TMC 2209s. That is in UART mode. That is controlled by the jumpers on the board and the settings in the firmware. My default axis per unit, I'm going to change 93 for the default extruder to 409 for the 3:1 inside the Hemera. And then after a quick run through here, everything else should stay the same in configuration.h. We will go take a look at configuration_adv.h. And the section that I'm most interested in right now is the auto fan pin section. This is where you can set up the fan pin to come on at a certain temperature. I want to use my fan pin on E0 auto fan pin. If you need to know how these are configured, you can take a look at the pins file. Over here on the left, do source, pins. We're on a 1769 processor, we'll expand that. We're on an STM32F1 processor, expand that. And then open up the Mini E3 V2 pins file. Now it's going to include a lot of the common files for the mini boards, so there might not be a whole lot of info in here, but they have reassigned the NeoPixel pins, PSON, and a few others. But the one I'm interested in is that fan 1 pin. It's on PC7, but you can also use it by calling it fan 1 pin. So I'm going to go ahead and copy that. But if you look down here, we have controller fan pin. It is also using the fan 1 pin. That can be set in configuration_adv.h. And for this default config, it is. So I elected to use that for my hot-end fan instead of my controller fan. Remember, you can do this whichever way you'd like. But let's jump back to configuration_adv.h. If you Control F and search for controller fan pin, we'll come down to this section. You'll notice it says the fan turns on automatically whenever any driver is enabled. That's what we saw when we turned the printer on and hit auto home. That's what it's doing. We've got this use controller fan enabled. And since it uses fan 1 pin, I can't use it for my hot-end fan. So I'm going to go ahead and disable this feature by putting 2 forward slashes in front of define use controller fan. And then I'm going to scroll down just a bit to the auto fan pin section. And instead of -1 right here on E0, I'm just going to put fan1_pin. That way it'll know to use those fan 1 pins where we plugged it in. And it will come on when it's over 50C, full blast. And that's all the changes I want to make, but one more thing. I want to take a look at sensorless homing. We'll just search for sensorless right here. And even though we're using those jumpers to control it, you would still have to turn it on in the firmware by taking off this comment. The jumpers are just going to tell it that we're going to be taking readings for the diag pins, not the end stops. But you still need to enable it. And you'll have to go through the process of setting your stall sensitivity. I do have a 2209 video that will show you how to do that. And just up from that is where you can control what mode you're running in, like Stealth Chop. We are Stealth Chop by default, as well as individual driver voltage. But all the defaults that they've done in this example should be just fine. So that's all the changes we need to make. So let's head over to the platform I/O icon over here on the left. We're going to scroll down and find STM32. We want the 103RE_BTT for Big Tree Tech. We're going to expand it, and we're going to hit Build. Now it's going to go through and download all the libraries it needs to build it. It should only take a couple minutes. And then we'll end up with a Firmware.bin file we can flash on our printer board. And our compile has completed successfully. Now we're going to mount the SD card that's on the SKR board on the computer. I'm going to go back up here to the left to the Explorer. And your Firmware.bin file that you need is up here at the top. .pio, build, the chip we're working with, this STM32 processor, and then Firmware.bin is right here. So I'm going to right click and say Reveal in File Explorer. Once that's open, I'll right click, copy. I'll pull open my SD card from the printer. There's a Firmware.cur file in there. That's fine, it can stay there. And I'll right click and paste my Firmware.bin file. This is the existing firmware. If you change that to .bin instead of .cur, it would reflash if you put the SD card back in there. So you can save this as a backup on your computer if you'd like. I'm not too worried about it, but if you want to go back to the original, save this one and just change the name and it'll reload it. Now that's done, we can put our SD card back on our printer, like so, and then we'll boot up. You can see Marlin 206, and from the screen, let's go ahead and reload EEPROM. In this version, I believe it does it for you, but it doesn't hurt to do it again. So we'll hit the button, we'll go to Configuration, and we'll hit Restore Defaults. This is going to bring whatever we just loaded from the firmware into EEPROM. We get one beep, and then hit Store Settings. We'll get one beep. That's just like doing an M502, then an M500. Now let's head to Motion, and we'll auto hone to make sure everything's working correctly. It looks good. Let's go to Temperature, and we'll preheat PLA. The preheat settings on this actually turn your part fan on 100%. It is running, so that's a good sign. Both the bed and the hot end are heating successfully, so that's good. And we're over 50 degrees, and I heard the hot end fan just kick on. So we know we have the fan pin settings just right. Last thing I want to check is make sure the extruder motor is turning the right way. Back to Motion. Move axes, extruder. We'll just go 10 millimeter. We're going in the positive direction. It's kicking out filament. We're good to go. Now, since we have an EEPROM chip, there's no need to keep your SD card in if you don't want to. You can switch out to other SD cards to get your G code. I've got my stock Ender 3 file that I like to test. I test the same G code on all of these. And assuming nothing changed on my bed level, everything else is good to go, I'm ready to hit print. And we are off and printing. Now, of course, because I use the stock Ender 3 config, the Humera is not going to be dead on for this config. I'll need to do some tweaks, like maybe a voltage adjustment or a PID tune, but you get the gist. You can work with this config from there to get it perfect. So there it is. The Big Tree Tech SKR Mini E3 version 2 board install is now complete. Now, I said it before, but I do think the version 2 board is the way to go. If you're looking for a mini board for a replacement for your Creality machine, or building another machine, definitely check out V2. Or if you have another mini board, like a 1.2, consider upgrading, because I think the features on this board are a lot better, they're going to help you out over time, and I think it's just going to be more consistent overall. Now, I didn't walk through auto bed leveling, or sensorless homing, or a complete Marlin config in this video, but I do have videos on all those topics, and they're going to be very similar on this board. So check out the links in the description below. Hopefully you liked this video, you found it helpful. That's all I have for you today, but I will leave you with some print examples from multiple boards just to see what you think. And I'll see you on the next one.